Alright, well let's try to... This is going to be a little tricky to recreate in... Alright, so I'll start with a triangle here. What did he do roughly to show... This was to show that root 3 is irrational. Can you sketch his proof?
So, he had 3 smaller triangles, like this size. Then he took them and sort of put them into the triangle. I think it was like, he made them overlap. Can't get them to overlap.
Here, yeah. This, I think they just have to be a little bit bigger to overlap. There you go. Okay. And then once he did that, what did he find?
So there were 3 smaller triangles that, and then for this triangle, they worked. For, you couldn't do the same thing.
And he was saying before that these 3 original triangles that fit into this large triangle were the smallest that you could do it for.
Okay.
But then he found that you could do it for a smaller pair. You have a smaller set of 3 triangles that fit into a smaller big triangle.
Interesting. Okay. So at the start he said, hey, I've got a set of triangles that's the smallest that does this. And he produced a set of triangles that also did it that were smaller. Okay.
Yep.
And so what did that mean?
So that means that root 3 had to be irrational because eventually there was going to be no solution to this equation if you could just keep doing it.
I see. Okay. Now let me give you this little challenge. If I had just sat down this morning and said, can you prove to me that root 3 is irrational? What would you have done?
So I would have done it the same way that you prove root 2 is irrational.
Okay.
So you assume that it's true. So you say that root 3 equals, say, x over y. Root 3 is a rational number.
Okay.
Then I want to get rid of the root 3 because integers are easier to deal with. So I say 3 equals x squared over y squared. Then I say, I get rid of the fraction. 3y squared equals x squared. So now you know, since this side is divisible by 3, you know that x is divisible by 3.
Okay.
X squared is divisible by 3, and then by extension x is divisible by 3. But you know that there's going to be an odd number of 3's on this side, and an even number of 3's on this side. So this is impossible. So 3y squared cannot equal x squared.
Interesting. Do you understand that proof?
Yeah, I think I do.
Okay. Alright, so now we have a geometric version of that proof. So that's actually pretty neat. Okay, so let's, the second thing you said you thought was interesting was the way you did it with different numbers.